Hi, today we will be looking at artificial intelligence. I'm Kester Rollins and this is iTech 360. Artificial intelligence systems. This is an alternative approach for using software and or hardware to solve problems. These systems mimic the workings of a human mind. Two types of artificial intelligence systems we will be covering in this chapter is an expert system and neural networks. Let's start with expert systems. An expert system exhibits reasoning that of a human expert to solve a problem. A knowledge base of the domain is used to develop its reasoning in the form of rules and inferencing mechanisms to determine if the rules have been satisfied by the system's input. A definition of a computer program is as follows. You will have the algorithm plus the data structure, and that will equal to a program. In an expert system, the relationship is somehow different. In an expert system, you will have inference engine plus the knowledge base, which would give you an expert system. A diagram of how the expert systems work. For instance, if you examine the diagram, you would see the knowledge base is the first part of the expert system. At this point, the expert will program its knowledge into the knowledge base, and then this is mixed with the inference engine to give a user output or a user interface. So for instance, this is a typical example of when you go to the doctor and there's a patient, so there's a doctor and a patient relationship going on there. The user would then say what is wrong with them, or the doctor can ask, well, what symptoms are you having and how are you feeling? And the user, based on the advice or based on the response given by the user, the system can then generate an advice to the user. If the user is not pleased with that or requires additional information, they can then input additional queries or additional questions, and it will compile an input that is suitable for that. In the knowledge base, or thinking about the knowledge base, we can say that the knowledge base contains facts. The rules concerning the domain of the problem is in the form of if-then statements. Let's elaborate on what if-then statements are. If-then statements are, if one particular situation happens, then this desired output is important. Or, for instance, let's say you have an artificial intelligence in your vehicle, your if-then statement could be something like, if the door is open, or if the wireless key is in the car, allow push to start to function. Speaking about inference engine, the inference engine interprets and evaluates the facts in the knowledge base in order to provide an answer. It compares the information in memory to the if portion of the rules in the knowledge base for a match. Once there is a match, the rule is ready to fire and is placed on the execution list. Execution list, as the name suggests, is the list of all the files or processes to execute. Certain rules have higher priority or salience. These will fire first before others with a lower salience. In this slide, we will be discussing chaining modes. Chaining modes is another aspect of expert systems. Expert system operates in either forward chaining or backward chaining. Forward chaining mode, The system acquires information and comes to a conclusion based on the information. Previously, we had an example with a patient and a doctor scenario. An example of forward chaining mode is if a patient comes into a doctor's office complaining about certain ailments, the doctor must infer what is wrong with the patient. He then observes the facts. If the patient has a temperature of 1 or 2, or he asks a question if the patient has been sick for 2 months, or if the patient has sore throat, from this aspect, he can then defer or concur that the patient has COVID or he has some other form of illness. In expert system forward chaining mode, this is how the AI operates. In backward chaining mode, when this is used, there's a large number of possible solutions to the number of inputs. Blackboard. Expert system Blackboard uses system reasoning methodology whereby a solution is generated by use of a virtual blackboard. Bayes' theorem. As with any human reasoning, there is some degree of uncertainty. Some may consider that to be the human touch. We are uncertain what color shirt to wear. Should we pass this way when we're going down the road? If we're in a particular situation, we wonder if this is the best way we can handle a situation. All these are certain examples of human uncertainty when it comes to reasoning and decision making, right? These uncertainty can be handled through fuzzy logic or Bayesian network, which is based on Bayes' theorem. If we look at the formula highlighted below, we will do some examination. This formula gives the probability of an event H given that an event E has occurred. Certain factors are easy to develop and use. These factors are the probability that a belief is true. For example, a probability of 85% can be assigned to object A occurring under certain circumstances. Some more on fuzzy logic. What is fuzzy logic and what is it used for? Fuzzy logic is used to address situations where there are degrees of uncertainty. Fuzzy logic functions help develop conclusions. System architecture. Let's review this diagram and discuss on it a bit. So what do we know so far? We know that fuzzy logic is used to address situations where there are degrees of uncertainty concerning whether something is true or false. This situation is often the case in real-world scenarios. A fuzzy expert system incorporates fuzzy functions to develop conclusions. The Inference Engine, as highlighted here, steps in fuzzy logic as follows. So then we have fuzzification. Fuzzification is a membership function defined on the input variables which are applied to their actual values to determine the degree of truth for each rule premise. We have inference, which is the truth of the premise of each rule is computed and applied to the conclusion of each rule. This results in one fuzzy subset to be assigned to each output variable for each rule. Touch on fuzzification a bit. Fuzzification The membership functions defined on the input variables are applied to their actual values to determine the degree of truth for each rule premise. Inference. The truth value for the premise of each rule is computed and applied to the conclusion part of each rule. This results in one fuzzy subset to be assigned to each output variable for each composition. All of the fuzzy subsets assigned to each output variable are combined together to form a single fuzzy subset for each output variable. We spoke about defuzzification. This is used when it is useful to convert the fuzzy output set to a quantitative number. Another aspect of expert system we will be discussing is spiral model. In the spiral model, we will be looking at analysis, specification, development, and deployment. Each circuit of the spiral adds some functionality and capability to the system. So let's just review the diagram and then we'll move on to discuss more on what each aspect is, right? So if you look, we have knowledge acquisition. Then we have to the bottom right, we have the coding aspect highlighted in red there. Then we have evaluating the expert system, which involves a few things. It involves testing, verification, integration, and validation. Then we have the planning aspect, which involves requirements, design, and validation. So you guys may be wondering, what indeed are all of these, right? So let's review in the following slides. In the spiral model, a key element in this process is the acquisition of knowledge. This activity involves interviewing experts in the domain field and obtaining data from other expert sources. Knowledge acquisition begins in the specification phase and runs into the development phase. Verification and validation of an expert system are concerned with inconsistencies. Inherent in conflict rules, redundant rules, circular chain of rules, and on-reference values along with their incompetentness resulting from unreferenced or unallowable data values. Aspect of artificial intelligence is neural networks. A neural network is based on the functioning of biological neurons. In biological neurons, signals are exchanged among neurons through electrical pulses traveling along an axon. When a pulse arrives at the synapse, it causes a release of chemical neurotransmitters that travels along the synaptic cleft to the postsynaptic. Application and development through 55 receptor sites on the dendrite side of the synaptics. The neural transmitter then causes a change in the dendrite membrane postsynaptic potential, or the PSP. These PSPs are integrated by the neuron over time. If the integrated PSP exceeds a threshold, let's say the neuron fires and generates an electrical pulse that travels to other neurons. In artificial intelligence, there is also something called genetic algorithms. This is another type of artificial intelligence technology involving genetic algorithms. As the name suggests, genetic and algorithms, we can probably see a correlation as to how this functions. So these algorithms are of the type evolutionary computing. Evolutionary computing uses the Darwinian principle of survival, which is the fittest mutation and the adaptation of successive generation of populations to their environment. The genetic algorithm implements the process through iteration of generations of a constant size population of items or individuals. Each individual is characterized by a finite string of symbols called genomes. The genomes are used to represent possible solutions to a problem in a fixed search space. So let's think of an example. If the population of the first generation of individuals consists of random binary numbers, and the problem is to find the minimum binary numbers that can be represented by an individual, each binary number is assigned a fitness value based on the individual's binary number. The smaller the binary number represented by a parent individual, the higher level of fitness that is assigned to it. So, through crossbreeding among numbers, known as crossovers, mutations of numbers, and pairing of numbers with high fitness ratings, the smallest value that can be represented by the number of bits in the binary number will emerge later or in later generations. Thank you for listening. That brings us to the end of our presentation on artificial intelligence. I'm Kester Rollins and this is iTech 360.